Question number 7. A particle P of mass 0.2 kg, so we have given the value of mass, is projected vertically upward from the horizontal ground with a speed of 25 meters per second. So initially it has a speed of 25 meters per second. Show that the speed of the particle when it reaches 20 meters above the ground is 15 meters per second. So when it reaches 20 meters above the ground, so 20 meters, we need to show that it has a speed of 15 meters per second. So we need to find the final speed. So we can use any of this equation. So v square minus u square is equal to 2as, and so we need to find the final value of v, and we know the initial velocity, that is 25 meters per second, and 2a. So s, we know the value of distance, that is 20 meter, or the displacement, that is 20 meter. And what is the value of acceleration? Since the particle is moving upward, so we have to take a negative acceleration, and if the object is moving downward, then we have to take a positive acceleration, because when the particle is moving upward, it would come to a point that it would come to instantaneous rest, and after becoming instantaneous rest, it would move down. So since we can see that the velocity decreases, so the acceleration would be negative. But for a particle that is moving downward, it would obviously keep moving downward, and it would not slow down until there is air resistance. So avoiding air resistance, we can see that the velocity would remains, or the velocity increases. But here we can see that the velocity decreases for the upward motion. Since the velocity decreases, so we have to take negative acceleration for upward. And you have to remember this, that for movement upward, the acceleration would be negative, and for the movement downward, the acceleration would be positive. So since the ball is moving upward, so the acceleration would be negative. So after substituting the value, we get the velocity as 15 meters per second, and we have to show this, that 15 meters per second. In part A, we can see that the particle P is moving upward, and it would move upward, and the height is given as 20 meter. So P is moving upward with a speed of 25 meters per second. So P is from this point is moving upward with a speed of 25 meters per second, and at this point, that means at the topmost point, or at 20 meter, it has a speed of 50 meters per second. So 50 meters per second. Now when P reaches 20 meters above the ground, it collides with the second particle Q of mass 0.1 kg, which is moving downward at 20 meters per second. So Q is moving downward at 20 meters per second, and this occurs at the 20th height, that means above 20 meters. P is brought to instantaneous rest in the collision. So while they collide, P comes to rest. That means the velocity of P is 0. Find the velocity of Q immediately after collision. So we can use the change in momentum. So momentum before collision. So before collision, P is moving upward. So before collision, P is moving upward. So we know the velocity of P, and we know the mass of P, that is 0.2. So mass into velocity of P plus, and initially Q is moving downward. So if you consider the velocity as upward as positive, then Q is moving down. We assume that the velocity upward is positive. So since we assume that the velocity upward is positive, so the velocity downward is negative. So downward is negative velocity, and we know the mass of Q, that is mass into velocity of Q. So this is for the initial, that is before collision. And after collision, P comes to rest, so mass into velocity, and since P comes to rest, so the velocity of P is 0 plus mass into velocity of Q. And we need to find the final velocity, that is the velocity of Q after collision. So the velocity of Q comes to 10 meters per second, and since the value of positive, so we assume that the positive is for upward movement. So since the value is positive, so we can say that it is moving upward. So when P reaches the ground, it rebounds back directly upward with half the speed it had immediately before hitting the ground. Find the height above the ground at which P and Q next collide. So when P reaches the ground, that means P from this point reaches the ground. When P reaches the ground, it rebounds back. So it rebounds, that means it again moves upward. So it rebounds back directly upward with half the speed it had immediately before hitting the ground. So immediately before hitting the ground, let's suppose it has a speed of v, that is immediately before hitting the ground, and after it rebounds it has half the speed. That means immediately before hitting the ground, let's suppose it has a speed of v, and after it rebounds it has a speed of v by 2. So when it hits the ground it has a speed of v, then if it rebounds then it has a speed of v by 2. So find the height above the ground at which P and Q next collide. So we need to find the height at which next collision occurs. So first of all, so initially we saw that P, a particle that is moving upward with a speed of 25 meter per second. So P is moving upward with a speed of 25 meter per second, and at the topmost point it has a speed of 15 meter per second at 20-meter height. So at 20-meter height, that is given that at 20-meter height it has a speed of 15 meter per second. So initially it is moving at 25 meter per second. Initial speed is 25 meter per second. Then at 20-meter height it has a speed of 15 meter per second, and at 20-meter height it collides with Q, which is moving downward with 20 meter per second. So P is initially has a speed of 25 meter per second. At 20-meter height it collides with Q with a speed of 15 meter per second, and Q is moving downward with 20 meter per second. And after the collision, we saw that P is brought to instantaneous rest. So after the collision, P is brought to instantaneous rest, and Q is moving upward with 10 meter per second. That we have found that after the collision, Q is moving upward with 10 meter per second. So initially, P is moving upward at 25 meter per second. At 20 meter height, it collides with Q, where P is moving at 50 meter per second and Q is moving downward at 20 meter per second. Then after the collision, P comes to instantaneous rest and Q is moving upward with 10 meter per second. Now, P comes to instantaneous rest, and after it comes to instantaneous rest, P then again moves downward, and as it moves downward, it reaches the ground with a speed of v, and as it rebounds, it has a speed of v by 2. Now we need to find height above the ground at which next collision between P and Q occurs. So first of all, what is this speed v? What is this speed v when it reaches the ground? So v square minus u square is equal to 2s. So v square is equal to 2as plus u square. So 2, and acceleration due to gravity is 10 meter per second square. So 10, and the distance is 20 meters. So the distance here we can see that it is 20 meter, and the initial speed, that is initially at rest, so the initial speed is 0. So we find the value of v, that is 20 meter per second or negative 20, and negative 20 is not the answer or inadmissible or not acceptable. So when it reaches the ground, it has a speed of v, and v has a value of 20 meter per second. So as it rebounds, it has a speed of v by 2, that is 20 by 2, that is 10 meter per second. So it rebounds with a speed of 10 meter per second. So now here we can see that P rebounds with a speed of 10 meter per second. That is v by 2, that is 10 meter per second. P moves upward with a speed of 10 meter per second. Now, as P moves upward, so what time does P took to reach from the 20 meter to this point? That is 20 meter from the height of 20 meter to the ground. So what is the time interval for P to reach the ground? So time for P to move to the ground. So time for P to move to the ground, that is from the initial rest to the ground, what is the time? So V is equal to U plus AT, and we have found that the final speed when it reaches the ground is 20 meter per second, that is 20 meter per second, and initially it is at rest, that is initial speed is 0. So initially it is at rest, plus acceleration is 10 meter per second square, and the time for P to reach the ground. So this is the time for P to reach the ground. So P took about 2 seconds to reach the ground. So P took about 2 seconds to reach the ground. So 2 seconds. Now, so P took 2 seconds to reach from the 20 meter to the ground. Now, what is the distance traveled by Q? So what is the distance traveled by Q? So first of all, to find the value of distance, S is equal to ut plus half at square. So by using the formula, what is the time for P to travel? So you have to remember that that when P reaches from the topmost point, that is above 20 meter, to the ground, it took 2 seconds. So when Q is moving upward, it took 2 seconds plus an extra time t, which is the time of collision. So this is the time t at time of collision. That is the next collision between P and Q. So this t is the time for the next collision between P and Q. So this is the time t for the next collision between P and Q, and 2 seconds is for P to reach the ground. So Q is moving upward with a time of 2 seconds. So this 2 seconds is the time for P to reach the ground plus an additional time t for the time of collision. So the time for Q, that is 2 seconds for 2 seconds. This time is for P to reach the ground. So when P reaches the ground, Q is obviously moving upward. So it is moving upward for 2 seconds. Then for time t, this time is the next collision between P and Q. Next collision between P and Q. So the time for Q is 2 plus t. So the distance Q, S is equal to ut. So what is the initial speed for Q? So initially it is moving upward with 10 meter per second. So initially, here we can see that Q is moving upward with 10 meter per second after the collision. So ut plus half acceleration is negative 10. Why the acceleration is negative 10? Because as it moves upward, the acceleration would be negative, but if it is moving downward, then acceleration is positive. So since Q is moving upward, so the acceleration is minus 10, 2 plus t square. So this is the distance traveled by Q, that is SQ is this value. So this is the distance traveled by Q before collision. Now what is the distance traveled by P before collision? So P has already traveled 2 seconds. That is 2 seconds to reach the ground. So P has already traveled 2 seconds to reach the ground. 2 seconds to reach the ground. So P has already traveled 2 seconds to reach the ground. So it has already traveled 2 seconds. Now it have to travel t second for the time of collision. So now it have to travel t second for the time of collision for P. So time for P is t second for the next collision. So time for P is t second for the next collision. So the time is t. So S is equal SP is equal to ut plus half at square, and P has the initial speed. So what is the initial speed of P? So what is the initial speed of P? So P from the 20 meter height took 2 seconds to reach the ground. Then after reaching the ground, it has a speed that is divided by 2. So 20 divided by 2, that is 10 meter per second. So it is moving upward with 10 meter per second. That is the initial speed is 10 meter per second. And the time is t for the next collision. So ut plus half, and since it is moving upward, so for movement upward, the acceleration is negative, half a t square. So this is the distance traveled by P, and this is the distance traveled by Q. So distance P and distance Q. Now, here we can see that as the objects collide, SP is equal to SQ plus 20. Why SP is equal to SQ plus 20? Because here we can see that initially P is at the ground, while Q is 20 meter above the ground. So P is at the ground, while Q is 20 meter above the ground. So P have to travel this 20 meter plus the distance traveled by Q. So P have to travel, that is SP have to travel this 20 meter plus the distance traveled by Q, that is SQ. So SP is equal to 20 meter, that is 20. So this 20 meter, that is 20 meter. So SP is equal to 20 meter plus the distance traveled by Q. So SP is equal to 20 meter, that is the difference in height plus the additional distance traveled by Q. So SP, that is SP is equal to 20 meter plus the distance traveled by Q, So if we equate this, we find the value of time, that is 1 second. So the next collision occurs when time t is equal to 1 second. So now the next collision occurs when time t is equal to 1 second, that is 1 second. Now find the height above the ground. So find the height above the ground. So you have to remember that the height above the ground. So what is the height above the ground? Now here we can see that Q is already 20 meter above the ground, but P is from the ground. So since P is from the ground, so we need to substitute the value of time in the equation of T, P, to find the height above the ground, because P is at the ground while Q is above the ground, and we need to find the value of height from the ground. Since we need to find the height from the ground, so we have to use the distance equation from P, because P is at the ground while Q is 20 meter above the ground. So we have to use the equation for P to find the value of distance. There is 5 meter. So the next collision occurs at a height of 5 meter above the ground. So the next collision occurs at a height of 5 meter above the ground. So above the ground. Now again, if we just recall, initially P is moving upward at 25 meter per second. Then at 20 meter height, P collides with Q. So P at this time has a speed of 15 meter per second and Q has a speed of 20 meter per second. Now as the collision between P and Q occurs, so P comes to momentary rest or instantaneous rest and Q is moving upward with 10 meter per second. Now as P comes to rest, then again P moves downward. So P moves downward and when it reaches the ground, it has a speed of V. Now as P rebounds, it has a speed of V by 2. So as P rebounds, it has a speed of V by 2. So what is the speed when it reaches the ground? So speed of P when it reaches the ground. So V square minus U square is equal to 2s. So V is the final speed when P reaches the ground and U is the initial speed that we can see that initial speed is 0. That is, it is initially at rest is equal to 2 as, and since P is moving downward, so the acceleration is positive. So after substituting the value, we find the value of V, that is 20 meter per second and negative 20 meter per second. So negative 20 is not the answer or inadmissible. And when it P reaches the ground, it has a speed of 20 meter per second. And as we can see that when it rebounds, it has a speed that is half. Since it has half the speed, so initially when it hits the ground, it has a speed of 20 meter per second. So when it rebounds, it has a half the speed, that is 20 by 2, that is 10 meter per second. So now it moves upward with 10 meter per second. So P moves upward with a speed of 10 meter per second for P. Now, time for P to reach the ground. So what is the value of time for P to reach the ground? So first of all, from the topmost point to the bottom point, what is the time for P to reach the ground? So to find the value of time, we can use the formula V is equal to U plus AT, where we know that the final speed when it reaches the ground. So final speed when it reaches the ground and not when it rebounds. So when it reaches the ground, it has a speed of 20 meter per second. So V is equal to U and the initial speed is 0 meter per second. So V is equal to U plus acceleration since it is moving downward. So the acceleration is positive. So after substituting the value, we find the value of time for P to reach the ground. So time for P from 20 meter height to the ground is 2 seconds. So 2 seconds, P took about 2 seconds to reach the ground from the 20 meter height. Now we refer the time t in these equations at the time of collision. T is the time of collision. So for Q, what is the total time for the time of collision? So what is the total time for P for Q before the collision? So time for Q before the collision. So here we can see that when P moves from this side to this side, so when P moves from the topmost point, that is 20 meter height, to the ground, so when P is moving, Q is also moving upward. So since Q is also moving upward, so Q also moves 2 seconds. So since P took 2 seconds to reach the ground, so Q also moves to this 2 seconds, and in extra time T, that is the time of collision. So Q moves upward 2 seconds, that is that P travels to reach the ground, that is 2 seconds, and extra time T at the time of collision. So Q have to travel 2 seconds. This 2 seconds is the time for P to reach the ground. So time for P to reach the ground, and for this 2 seconds, Q is also moving upward. So Q have to travel 2 seconds plus extra time T for the time of collision. So the displacement of Q is S is equal to UT plus half a t square, and from the equation we can see that, or from the given information we can see that Q is moving upward with 10 meter per second. So the initial speed is 10 meter per second, and the total time that we have found before collision is 2 plus t plus half. Acceleration is negative since Q is moving upward, so acceleration is negative at square. So after substituting the value, we find the displacement for Q. Now what is the displacement for P? So displacement for P. Now for Q, we have found the time, that is 2 plus t, and 2 is the time for P to reach the ground. So P has already reached the ground, and we have to find the displacement for P from the ground. Since it has already reached the ground, so it has already traveled this 2 seconds. So we don't need this 2 seconds right now, and P now have to travel this time t second for the time of collision. So from the ground, it have to travel time t for the time of collision. So Sp is equal to ut plus half a t square. So initially it has a speed of 10 meter per second at the ground. Ut, this t is the time of collision plus half a t square. So after substituting the value, and since it is moving upward, so the acceleration is negative, we find the displacement for P. Now, as the objects collide, displacement of P is equal to the displacement of Q plus 20. Now, why the displacement of P is equal to displacement of Q plus 20? Because as we can see that initially P is at the ground, but Q is already 20 meter above the ground. So Q is already 20 meter above the ground. Now, displacement of Q for the two objects to collide, P have to travel this 20 meter, P have to travel this 20 meter, and additional distance, that is SQ, that is traveled by Q. So P have to travel this 20 meter plus the additional distance traveled by Q. So SP is equal to SQ plus this 20 meter, because P have to travel from this point to this 20 meter plus the additional distance traveled by Q. So after equating that, the value, that is equation for P, that is this value, is equal to equation for Q, that is displacement for Q plus 20. So after equating this, we find the time. Now as we find the value of time, now we need to find the height above the ground. So we need to find the height from the ground. So we need to find the height from the ground. But as we can see that Q is already 20 meter above the ground. Since Q is already 20 meter above the ground, but we need to find the height from the ground. So we have to find the displacement for P, because P moves from the ground. Since it moves from the ground, so we can use the equation for P, because it moves from the ground. So after substituting the value of time in the equation for P, we find the displacement, that is the distance or the height above the ground. So we find the height above the ground at the where P and Q collide. So by substituting the value of time in the equation for P, because P moves from the ground, only P moves from the ground while Q moves 20 meter above the ground. But for P, it is moving from the ground. So after substituting the value of time in the equation for P, we find the height above the ground at which P and Q next collide. That is height above the ground at which P and Q next collide.